Okay, so yesterday we finished, or whenever before, might not have been yesterday, we finished graphing exponential functions. Today we're going to start graphing quadratic functions, okay? If we flip back in our notebook to the function types, quadratic functions are U-shaped. We actually call this a parabola. So this is a quadratic function, and that's what they're going to look like today. Now, just like an absolute value function, a quadratic function has something called a vertex. When we make tables in a minute, we are going to have to make sure our vertex is there so that we have a U-shape, okay? We're going to be using a calculator again because we're going to have to create tables for parabolas. Okay, so go ahead, open your notebook. We're on page 54. And we are labeling page 54. I can look. 19.1. We're skipping all over the place. Graphing quadratic functions. We're not actually skipping all over the place. We're doing it in a way that makes more sense than the book. Graphing quadratic functions. We will finish this lesson later. We'll only do one foldable today. We'll do another one later. All right, so once you have that, if you don't have a printer or anything, again, that's fine. That does not matter. You're going to write on this page. So I'm going to kind of move this. Fold this in half, and then we're going to get started. Okay, there are some similarities to this and absolute value, and that's finding the vertex. The vertex is h, k. That is where the similarities come from, where h, grabbing my pink highlighter, where h comes from here and k comes from here. When we did it before, remember, we would change the value inside because it was negative and it comes out as positive, and we would leave the one on the outside the same, okay? That doesn't change. We're still going to do that. So number 1. Oh, also, something that's missing from this is the a value in front. Write an a in there. For the most part, our a value is going to be 1, okay? It's the number in front. So in number 1, our a value is 1. So we're going to write 1, and then we're going to figure out the vertex. Okay. Our vertex, we have the first value, -1. We change that to a positive. We have -1. We leave that alone. It's like absolute value in that sense there, okay? We're going to see that better. We are going to take this value and put it in the center right here. 1, -1. We're going to cross this box out. We're only going to use 5 boxes instead of 6. So we always take the vertex and put it right here. Okay? Then we're going to make a table. So y equals, clear this out, parentheses, x minus 1 squared minus 1. Second graph. We are looking for 1, -1. It is right here. We're going to put the 2 numbers above it and the 2 numbers below it. So I'm going to put 0, 0 and -1, 3. Okay, and then the numbers below it are 2, 0 and 3, 3. So I'm going to graph these, then we'll figure out the rest of this. -1, 3, 0, 0, 1, -1, 2, 0, and 3, 3. It is U-shaped, so draw it like a U. It's not a V. That's absolute value. That's a V. This is U. Now we're going to identify our terms. The first thing we need to identify is our axis of symmetry. The axis of symmetry is where this is divided in half. This is divided in half right here at the vertex. This is the axis of symmetry. We won't draw it anymore after this one. The axis of symmetry is always x equals, this x value is 1. That comes from right here. That is the axis of symmetry. The x-intercept is not different than what we've done in the past. We've done this over and over and over again. The x-intercept is where it crosses. We have 1 at 0, 0. We have 1 at 2, 0. By the way, some words for x-intercept that you might see are zeros, roots, and solutions. That's on your quiz. It's going to say what other words can you use for x-intercept. Zeros, roots, solutions. Okay. The y-intercept is where it crosses the y-axis. It crosses the y-axis at 0, 0 as well. In behavior, when x approaches negative infinity, y approaches positive infinity. When x approaches positive infinity, y approaches positive infinity. It is pointing both left and right. The domain is all real numbers. The range is always y. Now we have to decide. From this vertex, is it pointing up or down? It is pointing up, so we say greater than or equal to. And then whatever the y value is, -1. So it is very similar to absolute value. We do have to make a table. The only addition is we have to find the axis of symmetry and these words, zeros, roots, solutions. Okay? All right, we're going to open this up and start number 2. Number 2, A, -2. Vertex, opposite, so +4, the same, +1. So we're going to cross this last box out. We're going to put 4 and 1. And we're going to make a table. Y equals, clear this out, -2, parentheses, x minus 4, close it, square it, +1. Second graph. If you're getting something different than me, make sure you understand this is negative, this is minus. Second graph. Okay, so we're looking at 4. So here's 4, 1, and the numbers above it are 3, -1, and 2, -7. Okay, and then we're going to have to arrow down to see the others. That's 5, -1. 6, -7. By the way, I don't know if you noticed this on the last one. The numbers right here, it froze. I don't know if you noticed this, it's still frozen. There we go. These numbers here and here are the same, and these here and here are the same. That was true in this here too. Same, same. That should happen in a quadratic. Okay, 2, -7. 3, -1. 4, 1. 5, -1. 6, -7. The axis of symmetry is where it cuts this in half. It is always x equals the vertex point, 4. The x-intercepts. I've said this to you a lot. We're going to have to guess because we don't know how to solve these yet. We will learn how to solve these after Christmas. Looks like it's about 3.5. And it looks like that's about 4.5. The y-intercept. I don't see a y-intercept. A y-intercept always exists though. Watch this. When I have a y-intercept, my x value is 0. So I'm going to look for it right here. 0, negative 31. A y-intercept always exists. In behavior, when x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, y approaches negative infinity. It is still all real for domain. Range, y, it's pointing down, less than or equal to, this point is 1. I would pause the video and start trying 3 through 5. Okay. Number 3. A, negative 1/2. The vertex, 2, 2. Cross out this bottom one. 2, 2. And then we'll have to find the rest of them. Y equals, clear it out, alpha, negative. And then alpha, y equals, enter. 1/2. Nope, nope, not there. Go over. By the way, the delete button helps you so you don't have to clear everything out. Okay, go over. Parentheses, x minus 2 squared plus 2. Second graph. Okay, I need 1, which is 3/2, or 1.5. 0, which is 0. 3, which is 3/2. And 4, which is 0. 0, 0. 1 3/2. 3/2 is 1.5, so we actually have 1.5. 2, 2. 3, 1.5. If you want to write 1.5 instead of 3/2, that's fine. 4, 0. Axis of symmetry is always x equals the x value of the vertex. The x-intercept is where it crosses the x-axis. Crosses in 2 places. The x-intercept can be none, by the way. 0, 0, 4, 0. The y-intercept, where it crosses the y-axis, crosses at 0, 0 as well. The end behavior. As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. Make sure you can see that. Let me move it up a little bit. Domain is all real numbers. Range is y less than, because it's pointing down, or equal to 2. Okay. Again, pause it. Try 4. Try 5. Okay. Number 4. A, it says negative. That means it's negative 1. Vertex is negative 3 because it's the opposite, comma 1. That goes right here. Cross the bottom one out. Y equals, clear this out, negative, parentheses, x plus 3. Close, squared, plus 1. And then second graph. Okay, I gotta go up. All right, here's negative 3, and I need negative 4, 0. I need negative 5, negative 3. I'm kind of blind. I really have to squint to see calculator. Negative 2, 0. Negative 1, negative 3. Negative 5, negative 3. -4, 0, -3, 1, -2, 0, -1, -3. The axis of symmetry is x equals -3. It's always this value. The x-intercept is where it crosses the x-axis. It crosses at -4, 0, and at -2, 0. The y-intercept is where it crosses the y-axis. We don't see that, but we don't put none. We look for it. It's where x is 0. So we're looking in our table where x is 0. Here's 0. 0, -8. The end behavior. When x approaches -infinity, y approaches -infinity. When x approaches infinity, y approaches -infinity. Domain is all real. Range is y is going down, less than or equal to. That point up here is at 1. All right, one thing I kind of want to add to this, and that's something called if your point's a minimum or a maximum, okay? The word minimum obviously means it's the smallest point. The word maximum means it's the largest point. In quadratics, as well as in absolute value, your vertex is either a minimum or a maximum. This vertex, because it is the highest point, is a maximum. It's just another word for the vertex, okay? We will talk about when it's a minimum, because number 5 is going to be a minimum. If it is pointing down, it's a maximum. Kind of like backwards of what you would think. Number 5. A is 2. The vertex is 4, 1. Put that here. Cross out the last one. Let's graph. Y equals, clear this out, 2 parentheses, x minus 4, close squared, plus 1. Second graph. All right, we got to go down. We don't need all these. Here's 4, 1. We've got 3, 3, and 2, 9. 3, 3, 2, 9. Okay. 5, it should be 3. It is. 6, 9. 2, 9. 3, 3. 4, 1. 5, 3, 6, 9. Axis of symmetry. X equals 4. X-intercept is where it crosses the x-axis. Does it? No. None. It is possible it will have none. It's possible we've all had 2, and it's possible to have just 1. If the vertex is on the x-axis, then it would be just 1. The y-intercept, we cannot see it, but it exists. It's 0, comma something. We got to go find it. It's right here in our table, 0, 33. In behavior, when x approaches -infinity, y approaches positive infinity. When x approaches positive infinity, y approaches positive infinity. All real for the domain. Now the range. Y is greater than or equal to, because it's pointing up, than this number 1. Okay, last let's talk about when the vertex is a minimum. This is the lowest point. So in this situation, the vertex is a minimum. You might be asked a question like that on your quiz, okay? All right, let's glue this in your notebook. We will have another day of this later. So fold it in half. We're going to glue it on page 54. And then I will see you for the next lesson later.